Alright, today we are going to start looking at proving that two triangles are congruent. In order for two triangles to be congruent, all of the corresponding pieces have to be congruent. All three pairs of sides and all three pairs of angles. Okay? So when we're writing our proofs today, they're going to be a little bit long, okay? Because we have to prove that all three pairs of angles and all three pairs of sides are congruent. So there are a couple of new things that we're going to use here, but most of these ideas we've already talked about. Okay? Things like definition of an angle bisector, or reflexive property, like those types of definitions and theorems and properties and postulates that we've already used. Okay? But one of the new ones that we're going to use today is called the third angles theorem. If I have shown that two angles of a triangle are congruent to two angles of another triangle, then the third angles have to be congruent. Right? There's no way for them to not be. Right? If I have two triangles, right, and I know this angle's 50 and this angle's 60, and I have another triangle and this angle's 50 and this angle's 60, right, once I've shown that two pairs of angles are the same, well, the third pair of angles has to be the same, right? In this case, both have to be 7, right? So once I've shown two pairs of angles are the same, I can just claim the third pair is the same by the third angles theorem. Okay, so let's start working through this proof here, okay, to show that all three pairs of angles are congruent and all three pairs of sides are congruent. So they give us a lot of information, right? They give us that first AB is congruent to CB. So obviously our reason is given. Now, we talked about before marking information on a diagram. This is where that's going to become really important. Okay, so I want to mark that on a diagram. I want to mark that AB is congruent to CB. So I'm going to put the same number of tick marks on each of those sides. Well, the next piece they tell me is that AD is congruent to CD. So AD is congruent to CD. That's also given to me. So that's these two sides right here. So I'm going to put the same number of tick marks on those. So I've already shown that two pairs of sides are congruent. Let's take a look at the information for the angles here. So I'm given first that angle BAD is congruent to angle BCD. So that's given. So mark that on the diagram. So angle BAD is this angle, and BCD is this angle. So I'm going to put the same number of arcs in those angles to show on the diagram that those are congruent. Then, the last piece of information they give me is that BD bisects angle ABC. Now, that piece of information doesn't directly tell me that anything's congruent, but if I know that this line, BD, bisects angle ABC, what can I say? What do I know? What's congruent? Not the whole triangle. Yeah, these two angles right here. Right? If BD cuts this angle in half, these two angles would be congruent. So I can say those two angles would have to be congruent. So I can't just call them angle B because I don't know which one I'm talking about. I would have to name those two using 3 points. So I could say angle CBD is congruent to angle ABD. To name the angle, yes, but technically, if I'm saying CBD, I want to use the same order of letters for the other triangle. So since A and C are corresponding pieces, I would want to name it ABD rather than DBA. So what would my reason be for that? Why can I say that these two angles are the same? Definition of an angle bisector. Yeah. So if we look at what we have so far, okay, I've shown that two of the pairs of sides are congruent. So I'm going to label that. I'm going to say here's a side, here's a pair of sides, and then I've showed a pair of corresponding angles, and then another pair of corresponding angles. So I still need another pair of corresponding sides and another pair of corresponding angles. Okay? Well, if I start with the sides, the last side for both of these triangles is the same side. They share a side in the middle. They share side BD. Present? So those two angles? Yeah. So we've already shown two pairs of angles are congruent. So now I can say the last pair of angles is congruent by the third angles theorem. Right? Once I show two pairs of angles congruent, then I can say, well, the third pair has to be congruent by the third angles theorem. So I'll put 3 arcs in there on the diagram to show that those are congruent. So I can say angle BDC and BDA. Okay. That's the third angles theorem. Okay, so I've got all 3 pairs of angles done. I just need this last pair of sides. So these two triangles share a side in the middle. Okay, it's actually going to be the same side that we're saying is congruent. Right? I'm going to say the last pair of corresponding sides is just BD is congruent to BD. It's not definition of congruence. What property lets me say that something is congruent to itself? Reflexive property. Okay? This is one that we're actually going to use a lot going forward. Okay? We didn't use reflexive property much at all in the previous chapter, but reflexive property, okay, whenever anything shares an angle or a side, we're going to end up using reflexive property to show that the same thing is congruent to itself. So now, I've shown all 3 pairs of angles and all 3 pairs of sides are congruent. Now I can claim that the triangles are congruent, and I can finally finish out the proof. So my last line here is going to be triangle ABD is congruent to triangle CBD. Now, our reason, okay, is listed up here. Okay, once we've shown that all pairs of corresponding parts are congruent, I can just say corresponding parts of congruent triangles are congruent. Okay, that's my reason for the 2 triangles are congruent. So we can abbreviate that to CPCTC. Corresponding parts of congruent triangles are congruent. Okay, once I've shown all 6 pairs of corresponding parts are congruent, then I can say the triangles themselves are congruent. Questions? Corresponding parts of congruent triangles are congruent. Okay, once I've shown that all corresponding parts are congruent, then I can claim the triangles are congruent. Feel okay so far? For today, yes. We will talk about shortcuts the rest of the chapter. But for today, we're going to show that all 6 pairs of corresponding parts are congruent. Okay. So, do you guys think you can try one, or you want to do another one together? Try one? Alright, why don't you guys try number 1 here? Les? Did I not change that on here? Not on the last one. I must have printed it out before I changed it. Yeah, I just made it a 2-column. Paragraph proof is just like writing this out in sentences. Yeah, I think the organization for this is much better than Well, we're not like shit that all sides. So yeah, the only thing it gives us is BD bisects both angle ABC and angle ABC. So from that, I can claim these are congruent and these are congruent by angle, definition of angle bisect.
Oh, yeah, both angles, C and both
Well, they aren't necessarily, like these two would be congruent to each other, and separately, these two would be congruent to each other.
Yes.
What's up?
Okay, I put your blank, but then I wasn't sure if it was your blank.
You can use vertical vertical angles or third angles theorem. Yep, both of those would be 100% correct. Usually we were given it as a midpoint instead of being called a bisector.
Yeah.
Yeah, I mean the word they use is bisects instead of midpoint. Did we get something like this for the first one? So, in the givens, I'm just given two pairs of congruent angles and two pairs of congruent sides. Alright, so those are pretty easy. Then the last piece of given information is that AC bisects BD. Okay? Usually when we did proofs before, we were told something about a midpoint instead of a segment bisecting another segment. Okay? But if we're saying AC bisects BD, that just means it cuts it exactly in half. So that means that these two halves of that segment would have to be congruent. So then we can claim that by the definition of a bisector, or in this case it's a segment bisector, not an angle bisector. Then the last pair of angles would be these two right here. So since I've already shown two pairs of angles are congruent, I could say that that third pair is congruent by the third angles theorem. Or in this case, we could also use vertical angles, because they're right across from each other. Okay, either of those would be correct reasons. Then we have all six pairs of corresponding parts congruent. Then I could claim the triangles are congruent because corresponding parts of congruent triangles are congruent. How do I remember? Corresponding parts of congruent triangles are congruent. It's universally accepted that CPCTC means corresponding parts of congruent triangles are congruent. Oh, you're gonna have to get used to it.
Thanks for your try.
All right, go ahead and try the last one on here. Okay, this one is slightly different. Okay, because these pieces of information we're given aren't all corresponding pieces, right? For example, we're told AB and AD are congruent. Those are sides of the same triangle. Okay, that's not a piece of information telling me that corresponding sides of the two different triangles are congruent. Okay, this piece just tells me these two sides in this one triangle are the same. No, they don't. Diagrams aren't always the same. Tomorrow. I'll teach you the first. Tomorrow I will teach you the first shortcut.
Why can't you just say,
So that you appreciate the shortcut more. You gotta do the long way first.
trust me?
You're just throwing.
No, I'm not a snake. I really can't.
Well, then you can use another shoe too. So yeah, you count all three pairs of sides. We also need to show all the angles as well.
That's so much.
This one is, yeah, it's a little bit long.
Expand your
Like,
brain.
we all know that it's the same. You don't gotta write all the angles.
Hey,
No.
I need you to give me a lab. No, what am I gonna use this elaborately as? Never, ever teach, or am I just
You're never
expanding my
going to
brain?
sit down and write a two-column proof in London.
So I'm just expanding my brain.
I don't feel like
So I have to get my
I don't care.
See, like that's how.
No, because math continually builds on itself. It's not like history where you can skip a lesson and then take the next lesson.
I don't know. I remember that in Fach, and
Sorry, yeah.
as you look up there. I know why
See, this one makes a little bit.
Well,
that's the whole point.
Correct.
Yeah, that's there's a third one.
So he's not read at all.
Yes, I had to change one word to two.
But then it goes back
You're
to
one that
say,
came
oh,
over. And when I heard a word, even if I had one. Yeah, one word was changed. Look, and now I also just know CPT.
it's just
Say what?
like,
Well, so have you already shown that these two pairs are congruent? Well, we would have to show that these two are congruent. These are congruent. Because B bisects both of those angles. Yeah, so I can say both pairs are congruent by definition of angles bisect. Then I can say these are congruent by the third angle. Really?
Yeah, it's not like we're like, okay. That's why we should. I didn't even
You think that the one view of
So like here, are you gonna have to write all of them down and then do all the proofs? I'm like you're gonna have to actually like write them down, or can I just do what I did the one day?
So the proofs on the air test, I've never seen one where you have to do the entire proof. It usually, yeah, like there's a few missing lines and you gotta drag and drop the correct
If that was
statements.
like, I swear, I walked right out of the room. I would.
and then
I think you would, knowing that graduation is on the line.
I mean,
That doesn't.
also
You know, those girls are like, they never want to touch stuff. And they go, this is where I belong. No, never mind. I think I know. We're gonna get back around. No, that's she's like, she's like, I still love that. Is she still? You know how? I don't think
so basically,
I don't know.